The twin paradox and Einstein mistake, a logical approach. See also a mathematical approach. These are advances on the book Logic in the Universe. What we want to show is that the time contraction is relative. Once the movement stops at any time and anywhere, the contraction disappears. Twin paradox was proposed by the French scientist Paul Langevin, based on Einstein's paper. The twins replace two synchronized clocks. This presentation has several shortcomings. He introduces gravity that does not appear in Einstein's paper. Clocks can measure seconds, which would not be noticed in a human being. We abandon Langevin. We are not interested neither in his relativity nor in his paradox. We could regain Langevin at the end of what we have to say. We return to Einstein. Consider two synchronized clocks at any point in space-time. Let one of the clocks move away, and when he comes back, he is behind. This is Einstein's paradox. In his paper, he proposed that the moving clock is slow by an amount second per second, which means that the delay is growing second by second. We can apply his formula at any second to know how much the delay has grown. Therefore, there is no need to wait for the moving clock to come back to the origin for measuring its delay. There is no jumping in the delay accumulation. Let us think of an experiment where the traveler's clock should be delayed on his return in t seconds. But when he was already late in half that time, a disaster takes place at the source, and the static clock completely disappears. The traveling clock doesn't know about the disaster and continues to move inertial as he was moving before the accident happened. Now you have to decide between the following options. The physical delay of t/2 is maintained but not growing. The physical delay continues to grow, but now, relative to whom? The physical delay completely disappears at the time of the accident. The delay is measured with respect to the static clock. Disappeared the static clock, it does not make any sense, any delay. But a permanent physical delay cannot disappear by an accident that does not concern him. Conclusion: the permanent physical time delay never existed. We have shown that time contraction is not a property of the moving clock. How can another property force a permanent physical change? Quintuplets counter paradox. Let us consider another experiment to show that when clocks stop, there is no delay. 5 quintuplets A0 to A4 synchronize their clocks at a point in space-time, then separate at different speeds. A0 knows his speed relative to the other 4 brothers and chooses to calculate his own age according to the others. The contraction on its own clock is K0 equals 0. Contraction with respect to other siblings is K1 to K4. A0 wonders for a moment and decides, I cannot have 5 different ages. Then my age is the one marked by my watch. The other ages my brother see and me are not physical ages, but relative to the motion. Therefore, these other ages are not permanent and should disappear when relative motion stops. It may be that someone is concerned about acceleration and its effects. In his article, Einstein did not talk about acceleration. Let us take away the acceleration from the previous experiment. 5 people agree to go through a given point in space-time at the same time. Each traveler gets to the point moving inertially, but at different speeds. At the time of coincidence, all synchronize their watches. Now you can repeat the previous experiment, but now without the acceleration. Positional correction. You probably have heard or read about the clock tower in the city of Bern that inspired Einstein in the formulation of special relativity. They say that withdrawing from the clock on a tram, he imagined he grabbed a ray of light and the clock stopped. Let us change the tower with a giant screen of a drive-in cinema, that place where cars arrive, park, and take a speaker to have sound and image. Let us take 2 points A and B located at 150,000 kilometers and 300,000 kilometers, respectively, from the screen. The frequency of the frames in the film is 30 frames per second. We have arrived in the middle of the show, and the screen displays a clock to tell the attendants when will begin the next session. At any time, an observer at A will have seen 15 frames, half a second, that B has not seen. The time B can see is behind in half a second of what A can see. If an observer moves from A to B, he will see fewer frames than anyone at A. When he reaches B, he will be delayed in half a second. The speed and the time taken are unimportant. Only their product, i.e. the distance, x equal v times t. The delay is given by x over c seconds. This contraction is permanent, provided that the observer remains at B. This may have confused Einstein, but if the observer returns to A from B to A, he will see more frames than those that are seen at B. When he reaches A, he will be half a second ahead with respect to B. I would like you to think about the next few lines. I used to send them as a heading in my letters when I presented the absurd of the paradox. Any given body at any moment in time is moving relative to millions of other objects. How one of them, family or not, can force a physical permanent absolute contraction by just observing it. Now I'm ready if you want to discuss about Langevin twins paradox. but I believe you are not